So question 19 again, this says solve the equation. And also it talks about excluded values here. So this has got a few things going on here on this problem. So I may need a little bit more room. So let me see if I can bring this down a little bit. Let's see here. Come on. Okay. All righty. So to solve this equation, let me pause for a second here. So again, to solve this equation, the first thing we have to pick up on, there's excluded values because the variables in the denominator. So what we want to do is we want to set each one of these denominators equal to 0. So we're going to have this x squared minus 1 is equal to 0. We're going to set this x squared minus x equal to 0. And we're going to set this x squared plus x equal to 0. Notice how this is actually factorable. I can actually change this to different squares. X plus 1 times x minus 1 is equal to 0. So all we got to do is ask ourselves is what makes these 0. So if we set x plus 1 equal to 0, and if we set x minus 1 equal to 0, we identified that, well, x equals -1 here and x equals 1 here. Those would be what would make that 0. Notice how this next one has a GCF of x in it. So if I pull the x out, this is going to give me x minus 1 inside left. So x came out, that leaves me an x. And when I pull the x out there, x divided by x is just going to leave me the 1. So if I set each one of those factors equal to 0, we'd have x, because this is still equal to 0, so x would equal 0. If I set x minus 1 equal to 0, we're going to just get x equals 1 there. So then if I have this x squared plus x equals 0, notice how there's a GCF there. If I pull an x out, this is going to leave me an x, and then x divided by x is going to just be a 1 there as well. So notice how if we set each one of those equal to 0, x equals 0, x plus 1 is equal to 0, we get x equals -1. So the excluded values, it looks like we would have -1 is an excluded value, 0 is an excluded value, and 1 is an excluded value. So if we look at this first equation, if I put a 1 or -1 in to that bottom, just use my calculator here for a second. So notice that if I do 1 squared minus 1, notice how that turns into 0 on the bottom. And again, we cannot divide by 0. If I put a -1 in, notice we have to use parentheses here. In parentheses, -1, close parentheses squared. If I subtract 1 there, notice how, oops, what did I do there? Subtract 1, hit enter. Notice how that also gave me 0. On this next one, notice if you put a 0 or a 1 in, that's going to be, if you put a 0 in, 0 squared minus 0. Notice how that is a 0. So that would make the denominator 0, and we can't have that. If you put a 1 in, 1 squared minus, again, you're going to replace that with a 1 as well. Notice how that also gives you 0. And the same thing for the last. If you put a 0 in, it's going to make it 0. And if you put a -1 in, it's also going to make that a 0. Let's just double check the -1. So in parentheses, a -1 squared plus a -1. That's going to give me 0 as well. So those are our exclusions. So when I solve this equation for x, I cannot get, I have to, if I get -1, 0, 1, I have to exclude it from my final answer. So let's go ahead now and let's just rewrite this problem. But notice how I've already factored the denominators, so I'm going to kind of take advantage of that. So x over, notice x squared minus 1, which we factored into x plus 1 times x minus 1. And then we have minus, then we have this x plus 2 over, and this x squared minus x, we factored that into x times x minus 1. Then there's our equal sign. Then we have a -2, and we have then, and this x squared plus x, we factored into x times x plus 1. So finding the exclusions also helped us kind of go ahead and factor the denominator out a little bit. So why do we factor that denominator? So remember, in solving an equation, looks fairly complicated. we want to simplify each side of the equation. I didn't see any parentheses, but what we did see is fractions are present. So if the fractions are present, we have to multiply by the LCM. So if you look at the denominators, we have, as far as the LCM goes, let me give myself some room here. So I'll put this down kind of towards the bottom. So notice that the LCM, notice how we have an x is one of the factors, x plus 1 is a factor, and x minus 1 is a factor. What's the most number of x's we saw? Well, this had an x, this had an x, this didn't have an x, so the most number of x's was just one x. What's the most number of x plus 1s we saw? Well, this had 1, this didn't have any, and this had 1, so I just need an x plus 1. And what's the most number of x minus 1s we saw? Well, this had an x minus 1, this had an x minus 1, and this had none of them. So the most I saw was just 1. So what we want to do to solve this equation is we want to multiply by this LCM, which is going to be this x times x plus 1 times x minus 1. So what I'm going to do is I'm going to come down here and write in this x times this x plus 1 times this x minus 1. And I'm going to use a bracket here. And then I'm going to put this inside the parentheses, or bracket, if you will. This is going to be x over this x plus 1 times this x minus 1. And then we're going to have minus then this x plus 2 over this x times this x minus 1. That's going to be the left side. And then on the right side, we're going to again multiply by this here. So I'm going to have to make this a little bit bigger for a second. So we're going to have again this x times this x plus 1 times this x minus 1. And then I'm going to have in my parentheses, or my brackets, if you will, I'm going to have then this negative 2 over this x times this x plus 1. So when I multiply this all out, notice how we kind of start with the bottom. Notice how this x plus 1 is going to divide out this x plus 1. This x minus 1 is going to divide out this x minus 1. So the only thing that's going to go through on the first piece is just x times x. That's going to give me this x squared. So then I have to multiply this x times x plus 1 times x minus 1 to the second piece. But notice this time, the x and the x minus 1 are going to cancel out. So what you're going to have is this x plus 1 is going to multiply to this x plus 2. So this is going to be minus then x plus 1 times x plus 2 over here. And then it equals, and then notice that the x and x plus 1 are going to cancel out. And that's going to leave me this negative 2 and this x minus 1. So to simplify this out, we still got to multiply this binomial times this binomial out. So this x squared is going to come down. This minus sign is going to come down. And then I'm going to have this x squared. And then we're going to have actually, this is going to give me a 2x. And this is going to give me a 1x. Because remember, the outer and inner have to go together. So 2x and 1x is going to give me a 3x. And then the last terms, 1 times 2 would be a 2. Then that's going to equal over here. I'll go ahead and multiply the negative 2 through. Negative 2x, and then negative 2 times negative 1 is going to be a positive 2. So remember, since there's subtraction present, we have to actually bring the subtraction sign through the parentheses and all the signs turn. So this is going to be x squared minus x squared minus 3x minus 2 is equal to then negative 2x plus 2. Notice this left side still has to be simplified. So notice how the x squared and the negative x squared will zero out. So this is going to leave me then a negative 3x. Oops. Let's keep the same colors here. So this leaves me this negative 3x minus 2 equals negative 2x plus 2. So after doing all that, we can kind of see that this equation is linear. So again, since it's linear, notice how we have this negative 3x and this negative 2x. I like to pick on a little guy, which I consider the negative 3x little guy. So the zero pair of a negative 3x is going to be a positive 3x. So I'm going to add 3x there, and I'm going to add a 3x over there. By doing so, the 3x and negative 3x are going to zero out. That's going to leave me a -2 over here. A -2 and a 3 is going to give me a 1x, or simply x plus 2. So then to get x by itself, we can subtract 2 on both sides, get rid of the constant. So if we lose 2 here, we got to lose 2 over here. So a -2 and a -2 is going to be a -4, equals then x. So after said and done, we're saying that the solution is a -4. Remember, our exclusions were a -1, a 0, and a 1. Since we didn't get any of those, our solution is a -4. Now, if we wanted to check that, we could substitute that into the problem. And also, that's kind of a booger bear to do, but you could possibly do this. So if I substitute a -4 in for x, so I have a fraction, so I have this alpha f1. Let's put that alpha f1 fraction. So notice I'm going to replace this x with a -4. On the bottom, since x is negative, we want to put it in parentheses. On this calculator, you have to. And then we're going to subtract the 1 there. And then we have a subtraction sign. And then we have another fraction, so alpha f1. We're going to have a -4 plus 2. Oops, what did I do this time? -4 plus 2. And then on the bottom, we're going to have, we're going to substitute -4 in again. So that's going to be in parentheses, a -4 close parenthesis squared minus then -4. And then that's done with the left side. If we hit enter, that's going to give us -1/6. And then on the right side, notice how we have a fraction again. Alpha f1, I have a -2. And we have in parentheses, a -4 close squared plus a -4. Notice that also gives me -1/6. So that is a solution since I made the left side equal to the right side. So hopefully you're practicing some of your calculator skills as well. So what I did, it would be a good idea to kind of make sure you can do that as well. Because the more you get familiar with this calculator, the easier it's going to be further down the road. So that concludes question 19.